This PowerPoint presentation is based on the 6th edition of Absolute C++ by Walter Savage, which was published in 2016 by Pearson Incorporated. This presentation is for the C++ programming class at Quincy College or anyone else who would like to listen to it. In Chapter 3, we will learn about predefined functions and programmer-defined functions. Functions combine related executable statements into one unit. An example would be a function named introduction, which asks the person for their name, address, and phone number and stores that information or prints it out. That function could be called by the main function or used many times in a program. Some functions return values to the main function. Some functions do not return anything because they output the information as part of the function. There are also predefined functions such as math functions and programmer-defined functions. One part of a function is the function prototype, which is declared before the main. Another part is the function definition, which is defined outside of the main function. This slide shows some examples of predefined functions. Some predefined functions require that #include CMath is included in the program, and some predefined functions require #include stdlib, cstdlib, which is from the C standard library. On the right, the expression sqrt, and then in parentheses 81, which is known as a function call. In the example, the result of sqrt 81 would then be assigned to the variable answer, which would be, in this case, it would be 9. Another predefined function is the random number generator, which is RAND and open and close parentheses. It returns pseudo-random numbers, and I say that because you might get the same numbers over and over again. And there's a way that you can make it more random, which I'll show you in the next slide. RAND doesn't use any arguments. It returns a number between 0 and rand_max, which is 32,767. Now, if you want to change that so that you get random numbers within a certain range, you can use rand, open and close parentheses, then the percent or modulus symbol, and if you say 6, it would generate the random numbers between 0 and 5. Let's say you have a program that's going to be throwing a die, and you want the numbers between 1 and 6. So you can use rand, open and close parentheses, %6, and then +1, and that would move it 1 ahead. To make the random numbers more random, a function is introduced named time. The value generated by time is constantly changing, which helps the random function generate numbers which are more random. When the time, open and close parentheses, when that function is used, you need to add #include and then arrow time arrow to the program. The next topic is programmer-defined functions. These are functions which you create. Some functions return a value and some functions do not. The add function, which is shown here, returns an integer, which is the result of adding the two arguments, num1 and num2, which are also integers. The print something function is a void function and does not return anything because it would have a cout statement which would print the results. The next topic is programmer-defined functions. These are functions which you create. Some functions return a value and some functions do not. The add function returns, what does that have to do with add? The function prototype is placed before the main function. It lets the main function know that the program will be using this function. The syntax for the function prototype is similar to the function header for the definition. The function prototype has a semicolon at the end of it, whereas the function header does not have a semicolon. The function definition is placed after the main function because a function cannot be defined within a function. The function definition consists of the function header and the executable statements which are part of the function. If the function returns something, then that is also listed as in the return statement. What's the difference between formal parameters and arguments? Basically, they are interchangeable, but if you want to get very particular about it, the formal parameters are whatever is in the placeholder in the function definition. It would be in the function header. So in this example of the add function, the int a and the int b, those would be the formal parameters. When a function is called, what you see inside the parentheses are the arguments. So the arguments are the values which are used in the main function to call the function. And the example, when you're calling a function, you just use the name of the function, in this case add, and then you have to make sure you give it the same data type that it is in the definition. So in this case, add's supposed to get 3 integers, so we can give it 3 and 5. Those would be the arguments. Another thing to note is if a function returns a value, the return statement sends that data back to the main function. If a function is a void function, then you do not need to include a return statement, or you can just put return semicolon. A little bit more about void functions. In the function prototype, you need to have void as the return type, and then you have the name and then any arguments, or if there aren't any arguments, you could just leave it within the parentheses blank, or you can put void there. So void functions do not return a value to the main function, but often what they do is they will output the results of calculations within their function so that they don't have to return anything. A void function does not have a return statement. You can use return with semicolon or just leave the return statement out. This function is called withdraw, and it returns a double, and it has a double as an argument. So when you get more sophisticated in programming, you need to think about preconditions. So before you'd call the withdraw function, you would want to make sure that the user had enough money to cover the amount that he'd like to withdraw. That's known as a precondition. Scope defines where a variable is valid. Local variables have local scope and are declared within the function and are alive as long as that function is active. When that function ends, that variable ceases to exist. Global variables are declared above the main function and are available to any other functions. This is a problem because another function could change the value of that variable, which was not supposed to be changed. The solution is that to create a global constant that is available to the other functions, but the functions cannot change that value because it is a constant. When you create a constant variable, you put const, C-O-N-S-T, in front of it, the data type, and then the name of the variable, and you need to give it a value.